Define microservice architecture. So, microservice architecture is a style of software engineering that structures an applications as a collection of loosely coupled services, which implement business capabilities. This structure is a variant of the service-oriented architecture, uh, the service-oriented architecture model, and focuses on breaking down applications into small, self-contained services. Each microservice is designed to execute a specific business function and can be developed, deployed, and scaled independently. Let's talk about some key characteristics of microservice architecture. Let's delete everything here. The first thing it will be the modality. Modality. Each microservice is a modular component focusing on a single business function. This separation allows teams to develop, test, deploy, and scale each microservices independently. Number two, decentralized control. So microservices promote decentralized data management and governance. Each service manages its own database and logic, which helps in maintaining data consistency and integrity specific to each service's functionality. Number three, diversity of technology stack. So, since services are loosely coupled, each microservice can be implemented using the best technology stack suited for its requirements. This allows using multiple programming languages, databases, and other tools within the same application. Number four, resilience. Microservices are designed to cope with failures. Since each service is a separate component, a failure in one service does not necessarily bring down the entire system. This isolated fault domain improves the overall resilience of the system. Number five, scalability. So microservices allow fine-grained scalability. Individual components can sorry. Microservices allow fine-grained scalability, so individual components can be scaled independently based on demand without having to scale the entire application. This is particularly useful in balancing system resources and optimizing costs. Number six, ease of deployment. So with microservices, it's possible to implement continuous integration and continuous deployment (CI/CD) practices more effectively, allowing frequent and reliable updates to live applications without downtime. And number seven, organizational alignment. So microservice architecture align well with organizational structures, often following the Conway's law, which suggests that organizations design system that mirror their own communication structure. Each team can be responsible for one or multiple services, allowing them to work independently from other teams. What is the benefits from that? What we get from all of that? So, the benefits of the microservice architecture, I guess, the first thing, it will be the flexibility that the microservices architecture offers. So, in using various technologies across different services, we got a lot of flexibility. Also, we enhance scalability. So, due to the ability to scale parts of the system independently, we are enhancing that scalability. Number three, we have improved resilience. So, as the failure of a single microservice doesn't impact the whole system, we improve the resilience. And number four, we have faster time to market. So, with the ability to develop, test, and deploy services independently, we have a faster time to market. But let's talk about some challenges because everything has its own challenges. The challenges of microservices, the first, which will be the complex in management. It's really complex to manage our microservice applications. So managing multiple services and their interactions can become complex, especially as the number of services grows. The second thing, it will be the data integrity. So ensuring data consistency across all services can be challenging due to decentralized data management. Number three, we have network latency. So increased communication between services over the network can lead to latency issues. Number five, or number four, sorry, testing complexity. Testing the interactions between different microservices can be quite complicated compared to testing a monolith application. And number five, it will be overhead. So the infrastructure and operational overhead can be significant. So as each microservice may need a separate load balancers, monitoring, and logging services. So in conclusion, microservice architecture is particularly beneficial for large, complex applications that need to be highly scalable and easy to update. It provides team with the flexibility to innovate and adapt to changing business requirements quickly. However, if requires careful planning, robust design, it requires careful planning, robust design, and effective management practices to overcome the inherent complexities associated with this approach. So that's it for this video, and see you in the future.